Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show because you love Python and want to keep your skills up to date, and machine learning is finding its way into every aspect of software engineering. Springboard has partnered with us to help you take the next step in your career by offering a scholarship to their Machine Learning Engineering Career Track program. In this online, project-based course, every student is paired with a machine learning expert who provides unlimited one-to-one mentorship support throughout the program via video conferences. You'll build up your portfolio of machine learning projects and gain hands-on experience in writing machine learning algorithms, deploying models into production, and managing the lifecycle of a deep learning prototype. Springboard offers a job guarantee, meaning that you don't have to pay for the program until you get a job in the space. Podcast.init is exclusively offering listeners 20 scholarships of $500 to eligible applicants. It only takes 10 minutes and there's no obligation. Go to pythonpodcast.com/springboard and apply today, and make sure to use the code AISpringboard when you enroll. Your host as usual is Tobias Macy, and today I'm interviewing Tzu-Ping Chung, Pradyun Gedam, and Paul Moore about their work to improve the dependency resolution capabilities of Pip and its overall user experience. So starting with you, Tzu-Ping, can you introduce yourself?
So I'm probably most famous of being the author of Markdown, a Markdown editor on Mac. And currently my occupation is as a freelancer based in Taiwan, and I was also the organizer for PyCon Taiwan for 2017 and 18. And I maintain PipEnv, although I've taken a step back recently because of the work I'm involved as a maintainer.
And Pradyun, how about yourself?
I'm Pradyun, as you said. I'm a college student still. I'm the youngest in the group today. I'm a Pip maintainer, a moderator on PyPI, a contributor to a whole bunch of open source software, and I guess another thing that's relevant might be I'm a co-dev on Toml. But yeah, that's a quick intro, I guess.
And Paul, can you introduce yourself as well?
Hi, I'm Paul Moore, as has been said. I'm a Pip maintainer. I've been a Pip maintainer for a number of years now. I'm also a CPython core developer, and I am the packaging BDFL delegate for interoperability standards, which is way too many words. But basically what that means is that I work with people in putting together standards, like the metadata standards for Python packages, and I'm in overall charge of sort of running those discussions and basically signing off on the final decisions made and the PEPs that come out of it.
And going back to you, Tzu-Ping, do you remember how you first got introduced to Python?
Yeah, well, as typical of my generation in Taiwan, I started at a fairly convoluted track. So my first programming experience is in college when I got my first ever notebook, which is iBook G4. And at the time, virtually nobody was using Macs. So Macs are lacking a lot of applications at the time. So I taught myself programming. Some of them is in Python, but just basic scripts to automate my workflow. And so I graduated from college and found a job as an iOS programmer because I used to program a lot of Objective-C. And so one day my boss just came up to me, hey, so the web guy just quit. Do you know anything about Django? I said, so it's Python, right? Okay, I can try. And then 10 years later, I'm writing 70-80% Python, and I haven't wrote a line of iOS code since.
And Pradyun, how about yourself? Do you remember how you got introduced to Python?
I do, yes. I think it was about 6 years ago, back when I was in school, high school. Dad gave me a book, Core Python Programming by Wesley J. Chun, and I had too much free time as a kid. And he basically handed me the book, said, "Hey, instead of playing that game, make one." And I was like, "Oh, okay, cool." Picked it up, built a game or two. I was like, "Hey, this is fun." And then I started diving deeper into the language itself, sort of seeing C Python exists and trying to understand what that means and failing at that because I didn't know C by then, obviously. Python was my first language and that's the only thing I knew. Then I realized I was using this tool called Pip. And well, then I dove into that and then stuff happened since then. And now I'm a maintainer.
And Paul, do you remember how you first got introduced to Python?
Oh, I'm not sure my memory is that long. I got involved with Python back in the days of about Python 1.4. I had an old Acorn computer back in the day, and it had no software at all on it. So I spent a lot of my time porting stuff to the Acorn. One of the things I looked at was Python, but didn't manage to get anywhere with it. But I came back to it when I got my first PC and got involved with the community. And I've never used Python as my work. It's always been a hobby for me. So I did a lot of playing around with stuff, got involved with community discussions, got involved with core Python discussions on things like imports, and that led to, I guess, things like zip import and then into packaging, ultimately to Pip, where there were things that I thought I could help with, got involved, and ultimately got invited to be a Pip maintainer and never looked back, really. So that's how I got where I am today.
And for people who weren't around in the earlier days of Python, I know that there were a hodgepodge of different approaches to being able to handle packages and dependencies, and Pip is one of the packages that came out of that and has become the standard for being able to install things, although there are some competing projects such as Conda and Easy Install. So I'm wondering if you can maybe give a little bit of the background and history of Pip and how we ended up where we are today, with it being the main way that people interact with getting packages onto their system for working with their applications.
Back in the day, the very original versions of Python, pretty much everything third party was just had a make file. You installed it with a make file with a C compiler, or you put things together yourself. It was very, very difficult. And as a Windows user, it was awful because everything was written for Unix and it was way too much work. The first big improvement was when distutils came along, which basically standardized the process for building stuff. That was a huge step forward. It meant that basically people could write their packages and have some level of confidence that anybody could build them. But it was still all very manual in terms of putting things onto your system. Distutils gave you the bits, but then actually installing them was still a problem. Pip came along around that time, and originally Pip was very much about taking the source code, using distutils to build it, and installing it. So it was the first real sort of package manager in that sense, but in those days it was very much, here's a package, get it on your system. And it had capabilities to do things like uninstall, which was quite a shock to the system in those days because that was really user friendly. Around the same sort of time, setup tools was invented, which was a slightly different approach involving trying to deal with managing multiple versions of packages on your system. It involved a lot of complexity and a lot of sort of cutting edge technology to do clever stuff, but I think I would be right in saying that a lot of what it did was fairly niche and not many people needed it. So Pip solved a lot of people's problems. It didn't help. Personally, for me, it didn't help a lot because it was all building from source, and source was still built with Unix compilers and things like that. But I have no idea when. It was a few years afterwards down the line. Daniel Holth invented the wheel package format, which was a format for building binaries and then just installing them onto your system. And that was added into Pip around that time so that Pip was able to take something that somebody else had built and just put it on your system. And it was at that point, I think, which Pip really started taking off because it made everything so much easier for people who didn't have the capability of building these things. In parallel with that, PyPI was coming along. There had been various attempts to build package repositories modeled on things like Perl's CPAN and things like that. But PyPI was the first real centralized place that people could put their packages, and Pip was built to get packages from there. So the combination of that was a step change for everybody in being able to get their packages all in one go. And that's really where Pip and PyPI came from. Conda that you mentioned was a similar type of effort, but that was built very much by the scientific community to deal with a lot of the specific problems they had around mathematical software, scientific software. And that developed in parallel, and to this day probably remains a sort of parallel ecosystem with a lot of similarities, but it's addressing a slightly different type of problem to Pip in terms of it's much more specialized. And I guess that's more or less where we are today. There are other things going on. There's been a lot of work being done in recent years to try and standardize things, to try and make it easier for tools to work with each other rather than people having to choose one and stick with it. And that's where a lot of the standards work I'm involved in comes in. And that's probably it.
Yeah, I got involved, I think, somewhere in the early 2.x series of Python, maybe around 2.3, and I can recall having to figure out what Python eggs were and ways to install them, and having to figure out how to uninstall them when I got it wrong. And I know that a lot of the ecosystem around packaging for Python and dependency management has just grown up organically, which is where we end up today with the work that you're doing to try and improve the dependency resolution capabilities. And so I'm wondering if you can just start by giving a bit of the background of the work that you're doing and the focus of where you're putting your efforts with this current body of work.
So the focus of the work that we're doing is fairly well scoped. We're replacing Pip's current dependency resolution algorithm with something else that's not broken. That's sort of the core bit that we're doing. The other part of it is we have user experience experts who have been brought on as part of the funding we've raised, and they are working to collect user data, collect user information, analyze it, and sort of work with us as Pip's maintainers and the broader community to improve the CLI, all the error messages, all the reporting in Pip to be more useful for the users.
And in terms of the overall scope of the work, you said that it's fairly well specified, and I'm wondering what the established criteria are for when it is considered complete and when it's ready to be handed off to the general Python community.
The criteria would probably be writing the replacement, getting it feature complete, which one good metric would be, hey, it passes all of Pip's tests. And then we're going to have a beta rollout, beta testing phase, where we're going to work with users. And we have user experience folks who can do user testing and have expertise in that area to collect feedback from them, see if the new resolver is actually doing the right thing for the users, is actually better than the existing resolver. The workarounds people have had over the years to work around the broken behavior of the existing resolver, they still work, or they have a clear path to removing those workarounds and things like that. So in terms of criteria, getting a feature complete and rolling it out with a beta phase and then addressing all of that feedback and making it generally available. Making it generally available is the this is done point.
And I know that there is a lot of technical debt that has been accrued in Pip over the years, and that there are some different pain points that people have had from it, dependency resolution being the main one. And I know that from looking through some of the posts and issues while I was preparing for this interview, that there was a fair body of work that needed to be done in advance of getting to the point where you could even start working on addressing the dependency resolution capabilities. So I'm wondering if you can talk a bit about some of that advanced work that was necessary and some of the main ways that technical debt manifests in Pip and some of the ways that it has sort of crept into the project over the years.
I guess a lot of it originates from the fact that Pip was originally designed to just take everything as source code and then build from there and get to the install state. And then when wheels were added, and sort of static metadata was a concept that was getting added into the code base. That's a transitioning that's probably still happening. In addition to this, as with any software project, the technical debt sort of grew organically. And at no point did people go, oh, yeah, let's hold off for a moment and clean stuff up. I mean, that probably happened a bunch of times. There have been major reorganizations, but none where it's, oh, let's remove this functionality and just keep the simple case, and things like that never happened. So one of the things that we had to do was break out these God classes, these classes that did everything, right? There is a requirement set class in Pip today, which earlier used to do everything. Building packages, fetching packages, dependency resolution, all of these happened within that one class. And it was like a few thousand lines of code. And so one of the things that had to be done was breaking this out into multiple pieces that did one independent thing and then bringing them together in not the requirement set object, but in the install command so that it's reusable components that we can use elsewhere. Similarly, there's an install requirement class that does too many things that we're slowly breaking up. But yeah, it unifying code flow across the code base so that we're not going through three different parts of the code base for the same thing, like three different approaches to building source distributions from directories and things like that. We're still cleaning a lot of this up, but at this point, we're reasonably good on the, rather, at the point where we decided we're reasonably well separated the dependency resolution from the rest of the technical debt is when we went, yeah, we can probably like expedite this work with some funding. And yay, that happened.
So while Pradyun was busy doing the restructure and refactoring stuff, I was a maintainer of pipenv, and pipenv was and it's still using pip tools as its dependency resolver. And pip tools just uses pip's internal dependency resolver, which is, as we have already discussed, is not very good. So me and two other maintainers decide to, hey, let's just write a brand new one for Python because there was no such thing at the time. So we set out to implement a simple backtracking resolver for pipenv, and we called it resolvelib. But all of us got busy afterwards, and we never really quite finished the project and just sat abandoned over there and never got integrated into pipenv. And one day, there's a guy named Pradyun just came out to me, hey, I was doing some resolver research and I wrote a thing called Zazzle, and I figured out that it's actually fairly similar to what you were doing. So that's basically how I got on board to this body of work. And maybe Pradyun, you can take it from there.
Just wondering what role each of you are playing in this body of work.
I got involved initially in this space, dependency resolution as a whole in Python packaging, as part of Google Summer of Code. I had been contributing to Pip for a few months now, and then Google Summer of Code happened, and I realized I'm eligible because I'm in college now. So I applied. We made the logistics of it work, and I ended up having 3 months of time where I could just work on Pip, and specifically with a focus on improving dependency resolution. That's around the time that I was working on paying down this technical debt. That's when it started, as well as writing Zazzle, as Tzu-Ping pointed out. So right now, I'm sort of, at this point, I've been involved in this getting Pip's dependency resolver much better for like 2.5, 3 years now. So I have a lot of sort of a good understanding of that, very deep understanding of Pip's code base and how it's quirky and how resolvelib works, and I've built these mental models over the years. So I'm sort of contributing that and a bunch of code toward making the resolver happen now. And I guess over to Paul.
Right. I've been involved as a Pip maintainer for quite a while, and I did a lot of work on the PEP517 build implementation for Pip. So I was made aware that there was an opportunity to get involved in doing some work on the resolver full time, which basically I grabbed at the chance to do that because it looked like really interesting work to get involved in. I've been picking up the resolver side of things from there, and I guess, just fitting in, doing chunks of the coding, implementing bits of the features that need to be added into the resolver implementation. I've also been trying to sort of keep an eye on the question of how this fits into the various standards that we've got. Obviously, I've got an interest in that. So things like how metadata is provided to Pip, that's something I'm sort of trying to feed back into the wider community, how we manage the data that Pip needs in order to do the resolution. So I guess that's where I fit in.
And also doing a big chunk of the implementation along with Tzu-Ping.
And so, in terms of the current state of affairs, what are some of the ways that people might experience the broken dependency resolution of Pip, and how is it currently implemented?
I take this one.
Go on.
Basically, for a lot of cases, the current resolver is fine. But what happens is that when a project has multiple dependencies, and particularly when you're trying to install multiple things at once, and the dependencies are either in conflict or are difficult to resolve, Pip's current resolver takes the approach of effectively first come, first served. So it goes through in order, says, I'm going to try and make this one work. Okay, that worked. On to the next one, on to the next one. If, as it goes further down the line, it finds something that conflicts with what it's already done, it doesn't backtrack and try again. It just says, oops, and finishes off as best it can. And the result is that for that type of situation, what Pip installs is actually broken. You may have project A depends on version 2 of project B, and what Pip actually installs for you is version 3. And it says, sorry about that. And then you've got to dig yourself out of the mess, which isn't difficult to do, because what you can do is just uninstall the wrong version and install the right one. But for a user, it's knowing that's happening. It's finding out what needs to be done. It's basically doing the job that you wanted Pip to do, you've got to do manually and pin all your dependencies as a result of it.
And then as far as the workarounds or resolutions that people can apply manually, what are some of the common practices that people have had to resort to in the absence of a robust dependency resolver?
A lot of it is that type of thing. It's pinning the requirements more tightly than they would like to, particularly in libraries, which is obviously bad. You don't want tight requirement pinning in libraries. People are doing things like installing without dependencies and then manually installing the dependencies. There are a number of other projects which have been built up around the packaging ecosystem with the intention of doing the resolution outside of Pip. Tools like Pip Tools, for instance, does that. Poetry, the project management tool, was explicitly built. One of its goals was to try and do dependency management on top of what Pip provides. So there's various different things people do, but at the end of the day, it's trying to manually do stuff that Pip ideally should be doing for them.
And in terms of the new dependency resolver, how are you approaching that implementation, and what are some of the constraints that exist within the Python ecosystem that are influencing the overall approach?
So in terms of the new resolver, one of the things that we're doing is we're using a reusable component, resolvelib being that reusable component, which defines an abstraction layer between the dependency resolution algorithm, the part that does, oh, let me fetch this one, let me see this one, let me backtrack this choice, and all of that algorithmic logic, from the pip specific details, like here's how I get dependencies of a package, here's how this package should be represented, and this is what describes the package, and things like that. And by separating these details, we're allowing both of them to evolve independently. So we could slot in a new resolver in the future date that's actually somehow better than the one we already have, because there are various dependency resolution algorithms in broader space of dependency resolution. So that's one of the decision we made is having an abstraction layer so that we can swap the underlying resolver algorithm data if we want to. The other part is we are not trying to make the existing resolver morph into this new resolver. No, no, no. We're going to implement a new one all over again because the structure of code, the assumptions that the old resolver made that I'm never going to backtrack are really baked into not the data structures, but the code structure itself. So it just makes a lot more sense to not bother dealing with that bit of debt and just rewriting that. Building on top of resolvelib, so we don't actually have to write dependency resolution algorithm, only implement Pip's own details, things like here's how you get metadata and things like that on top of resolvelib. That's one of the design decisions that we made to ignore the existing resolver in the implementation and to make a new one. The other benefit of this is that we can have a nice rollout approach to this, which is we can have both the resolvers in Pip at the same time for users to test with, right? So that's useful for when we do the rollout because we can just keep improving the new resolver until it's at feature parity / better than the existing one, and then flip the switch once we know it's not going to be disruptive to do so.
Okay, so Paul, do you want to mention the resolution logic?
One thing that people may or may not know is that dependency resolution is a fairly well-known problem. There's lots of things that deal with it. The technical terms are SAT solvers and things like that. So there are libraries that do dependency resolution as a general problem, and many languages already use some form of that. The problem that we have in particular with Python and with Pip is that most of those libraries and most of the sort of algorithms behind the process work on a basis of assuming that they know all the details of the problem up front. So I know what packages I'm being asked to install, what dependencies they have, what versions are available. That's all available to me, or at least easy to get. Unfortunately, due to the history of how Python packaging came about, a lot of that just isn't easy to get hold of for Python packages. So, for example, if I'm trying to install a project that's sitting in a directory on my PC, I can't even necessarily know the name of that project without running through a build process. So asking questions like, does this project satisfy this version dependency, can involve wheeling out your C compiler to an extent. And that means that algorithms or libraries that work on the basis of they can just freely go and check versions are going to be really badly performing for Python and for Pip. So one of the big challenges for us was to find a library and an algorithm that would minimize that impact so that we would, as near as possible, only calculate what we needed to know and nothing extra. And that's where resolvelib really came into the equation, because the decision to use resolvelib was because it basically only got information on demand, and we could use that to feed it with Python data without having that excessive cost.
Another element that I'm sure factors into the overall complexity of this problem is the existence of self-hosted or third-party repositories as well, where you can't even necessarily rely on the capabilities of what's in the PyPI server of warehouse. And so I'm wondering how that also influences your decisions on how to approach this problem or the capabilities of dependency resolution in those contexts.
Probably not as much as you might originally think. I mean, the worst case scenario for Python and for Pip is installing a project from your local disk, just the source of the project that's in development. That's a key use that people have for Pip. And basically, if we can cover that, then pretty much anything else is easier, because the biggest problem that we have in all cases is metadata. It's what's the versions, what are the dependencies. And as I say, the good thing about the existing code base for Pip was that we already had a lot of that machinery in place. The build process is already there. We just feed it a project, and out pops a built version with the metadata we need. So where the problem of having different sources of data does hit us, and it's something that people will have been aware of, is when it comes to looking at what projects are valid, what, for example, wheels, what binaries are valid on a particular environment. One case that came up recently was when setup tools dropped Python 2 support. And so in order to install setup tools on a Python 2 environment, you have to pick an older version. Now, there's lots of ways of getting that data. Specifically, there's three. There are tags built into the wheel specification which say this wheel is only usable on Python 3. That's great, but unfortunately, what that does is it causes pip to fall back to building from source. So just saying that your wheel is only available for Python 3 doesn't really help, because pip will then say, okay, I'll build from source. Within the standard Python metadata, there is a piece of metadata that says this project works on Python versions X, Y, and Z. And that is what's used as a sort of final resort, because that's the metadata that we need to build in order to get. So what will happen there is, if we build a project and it turns out to be for a version that doesn't match the current environment, the new resolve will at that stage backtrack and try again. So there'll be a bit of a cost in building, but that's it. The old resolver had a big problem here, because by the time it had built the project, it had already committed. And so you ended up with people under the old resolver getting an incompatible version installed. And that is one of the things that we wanted the new resolver to fix. The other place where you can get the data that requires Python metadata is also exposed on the package index as part of the data that PyPI provides, and pip uses that to catch the problem early. That is great. That saves an awful lot of processing from pip's point of view, because it can discard a lot of things straight away. It's the one place, though, where if somebody is using a different piece of index software that doesn't support that data requires Python tag, then they won't get that benefit. And they will have seen with the current version of the resolver, pip will install things that potentially don't match. So that's probably the main place where the various different sources is going to make a noticeable difference.
The other sort of important thing here is we are not directly using all the information from PyPI. So I'll need to go in a bit of technical detail, but basically there's a page that lists all the versions of a package that are available on PyPI, and that page contains the data requires Python information, like some metadata about the package. Here's the name of the file. Here's what version it is. Here's where you can get the file. Here's a little bit more. But very importantly for dependency resolution, this does not include dependency data. So we do not rely on this page for getting, Flask requires these bunch of packages. Like, no. That's not what the resolver sees. What the resolver sees is, okay, these are the available versions of Flask, and that's one of them is what I'm going to get for Flask. And then when we get it locally is when we trigger the build to get dependencies. Because essentially, because of history, we have an executable file, a setup.py file, which needs to be executed to get canonical, definitely correct, in air quotes, metadata about a package. And that's the build step that Paul's talking about, is we need to do the, hey, setup.py, tell me about this package step, which is expensive. And in dependency resolution, when getting dependencies is an expensive step, it's a slow process overall. It takes a lot of optimization to make sure we're not going in the wrong direction. And backtracking will mean that there's going to be, I made a bad choice. Let me go and do all of that all over again with different set of choices. Right now, we're not going to enhance any of the interoperability standards for basically letting package indexes like PyPI and other third-party package indexes to give this data to pip, partly because that requires writing a PEP and getting a lot of work done, because it's a standardization problem and there's a lot of use cases to consider. People use Python in all sorts of ways. So until that happens, for now, what Pip's going to do is it's going to get the package and generate the metadata and get the dependencies. That's going to be slow. One of the big speedups that we want to do after the initial rollout of the resolver is working on that as volunteers that we have been for so long, is getting that standardized so that we can make that work for not just PyPI, but all third-party package indexes. And to sort of hint at why we do this is we've been burned by having implementation defined standards in the past where, oh, this works because that's how it's been implemented, and what's implemented is how we do stuff. Instead of going, this is how we do stuff, and let's implement that from a piece of text to code. So we've been moving away from that through the standardization efforts that the Python Packaging Authority and the broader Python community has been doing in this space. And yeah, so we are not going to introduce more implementation specific stuff, implementation defined stuff, while also working towards reducing doing that. So that's why we're not going to use information that PyPI does provide in like a PyPI specific API until we standardize it and make it possible for third-party package indexes to expose the same information.
Yeah, and going back to Paul's example of setup tools, it's something that I've personally been burned by because I've got a Python 2 project that I have to maintain at my work, and creating the virtual env for Python 2 and then having it install setup tools greater than 45 and then just having everything break and having to manually override that. So I'm definitely looking forward to this new resolver being mainlined into pip. So keep up the good work on that front. And then, so in terms of the new capabilities that you're hinting at and some of the new standards that you're looking forward to, what are some of the overall improvements in pip itself and some of the surrounding packaging ecosystem that you either anticipate or that are explicitly blocked by this work?
So one of the big ones is better environment management in pip, which has been something that lots of folks have been asking for. The other is the dependency resolution logic is now going to be in a shared library. And so not everybody in this space will be implementing their own, and we'll have at least some way to do interoperability. Although this is implementation defined, but it's also a lot closer to the implementation. So the other is it will help simplify some of the other tooling in the ecosystem. So as Tzu-Ping hinted, pipenv depends on pip tools, which depends on pip's internals. If pip's internal resolver improves, pip tools improve and pipenv improves. Similarly, other projects that are using pip under them for whatever reason, they benefit from this work as well. And another thing that's been very common is being able to upgrade packages without breaking the existing packages, which I want a newer version of Django. And oh no, now my extensions don't work. Now my plugins don't work. Now my other applications don't work. Like that should not happen. And that's one of the things that this resolver will enable in some senses. Although that's something it should be doing already, but it's not. So
that's definitely something that I've been burned by as well. And I'm sure many people have also, of running pip-u for a particular package and having it bring along a half dozen other things that you didn't anticipate.
Yeah, that got fixed at some point partially, but it was more of a workaround. It stopped upgrading everything it saw and only things it needed to. But again, that wasn't ideal, and doing a proper resolver solves that much better and more correctly.
And Tzu-Ping, as somebody who is maintaining one of the projects that is dependent on pip, what are some of the improvements in pipenv or some of the other projects that you maintain that you are excited to be able to get started with once the resolver ends up in mainline pip?
So, as we previously mentioned, pipenv currently depends on pip tools, which depends on pip. But one of the, optimizations pip is doing in this dependency resolution logic is it only resolves the dependencies for the current environment. So, for example, if you depend on Django 3.0 on Linux, but you for some reason want to depend on Django 3.1 only on Windows, then the current pip resolver, even the new pip resolver, will only choose either 3.0 or 3.1 based on what platform you're currently on. But for pipenv or for example, poetry or maybe pip tools, the ideal scenario would be to generate an, I call it abstract dependency tree. So it will need to generate a log file that says, hey, if Windows, then install Django 3.1, otherwise Django 3.0. And this is one of the things I am looking forward to do by like learning with while I'm learning from the work I'm doing in Pip. I can translate all the knowledge to building a better abstract dependency resolver for pipenv and other similar tools.
And as part of the overall project, you mentioned too that you have a user experience team who are conducting user interviews. And I'm wondering how some of that has fed back into your plans for this project and some of the ways that it has influenced your original ideas or changed the direction that you're taking for the technical implementations.
Yeah, so if I start from ResolveLib, so because ResolveLib was kind of developed in the vacuum without a actual use case until Pip decided to choose it, one of the things that ResolveLib does not do well is error reporting because we don't have real world example to report on. So one of the biggest advantage the user research team are feeding back to us is how people are thinking about Pip's error reporting on dependencies and how we can do it better potentially in the new resolver.
I think one of the other things that has been very valuable, certainly speaking as a Pip maintainer, is just simply getting a view on how people are using Pip out there. I mean, obviously, we see reports of what people are doing, but a lot of what we get in the normal course of events comes from people raising issues. So optimistically, I assume that we're getting a fairly biased view of how bad Pip is from only ever seeing bug reports. And one of the things we've definitely got from talking to some end users about how they use Pip, what they use it for, how it works, I was actually quite surprised that a lot of people were finding that they wanted Pip to be more strict, more definite, more precise in what it did, and they weren't trying to do bizarre, weird, and wonderful things, and they wanted to force Pip out of its comfort zone. They were actually just trying to get on with fairly straightforward stuff, and they just wanted Pip to continue doing what it did, but better. So that was a really sort of positive bit of feedback, and also reassuring that when you're trying to deal with a problem like dependency resolution, you spend your life mired in ridiculously complicated examples of 20 things all independent, all interdependent on each other and all conflicting, and how are we going to deal with this problem? And getting that step back and getting the feedback that most people have relatively straightforward environments with relatively straightforward problems they want to see fixed. And if we do that, we've solved a lot of the problems. That puts a great perspective on what we're trying to achieve and makes it more achievable ultimately.
Yeah, and yeah, I just strongly agree with what Paul said, that with a Pip maintainer hat on, like, I think the most valuable bit of information has been some amount of improved visibility into how users are using Pip, because to put it mildly, a lot of people are using Pip, and we generally don't see a good chunk of, hey, Pip just worked, because the normal communication channels are biased towards, hey, Pip did not work, or hey, I want Pip to do this other thing as well. So getting that sort of perspective, as Paul put it, has been super useful. The other bit has been some amount of better, not sure what the word would be, better mental model for approaching user-facing changes as part of learning about these topics from people who are experts in the space, and sort of getting, at least for me personally, getting their take on how to handle some of these disruptive changes that we might make in the future, or sort of communication around those, and how to handle telling users about these, and so on. And that has been useful as well. So hopefully that translates into slightly nicer experiences for users moving forward.
And when it comes time for people to start using the new resolver, is there any work that they're going to have to do on their end or changes to their workflow? Or is it something that will just land in Mainline and it should essentially be invisible to end users, other than the fact that they'll start getting fewer errors from their installs?
It should be as simple as that. The plan for the rollout is that right now the new resolver is available using a flag within pip, so you can enable the new resolver by saying unstable feature equals resolver, and you can see how it's working and how it's progressing. It's obviously only very much in an alpha state now. At the point where it's finally released, that unstable feature flag will no longer be needed, and the new resolve will just be there. Hopefully, the goal is that will have as little impact as possible, but obviously, as we talked about, people will have been working around existing issues. People may have breakages in their environment that pip has installed things with conflicts, and so we're going through a process at the moment, and we'll be continual. There's going to be a proper beta release of the new resolver, which will be publicized later in May, I believe. And at that point, we're looking for people to actually try and exercise the new resolver if possible, or more generally, run pip check on their environment to make sure that they don't have issues in their existing installation, which when the new resolver comes along, it might say, I'm sorry, I don't see how you could possibly have this. I'm not going to deal with it. Because obviously the new resolver is designed to avoid conflicts. And if you hand it an already conflicting environment, it's going to have problems. So a little bit of pre-work on the part of users to make sure their environments don't have such problems. In terms of maintaining their projects, looking at how they're specifying on their dependencies, are they doing anything at the moment to work around resolver issues, and what's their plan going to be for maybe getting rid of that? The workaround should carry on working, but they'll, rather than being necessary, they'll change to being suboptimal. So ideally, people should look at planning to phase them out once the new resolver is in place. So there are things people can do, and it will help both them and us to get the new resolver in place. But for hopefully the vast majority of people, just enjoy the benefits of pip not breaking your dependencies for you.
And then in terms of the broader ecosystem and broader experience of people using pip and programming in Python, how do you anticipate these improvements in pip impacting the overall viability of the Python ecosystem and its use within different communities or industries that might be shying away from it because of some challenges that they've faced in dependency conflicts?
Hopefully, I think the main thing would be that I think if you take it from the other angle, at the moment, dependency resolution in Python is known to be not perfect, shall we say. So there will be people that are looking at their project and saying, should I use Python? We've got an awful lot of dependencies. Is it going to be okay? And hopefully having a better story around how the resolve works and dependency resolution mean that people will be more confident in saying, yeah, I can choose Python because dependencies aren't a problem. So, I mean, I don't want to sort of make it sound like we're going to solve all the problems of the universe here, but a little bit more enthusiasm for Python because it doesn't have as many concerns around it will hopefully improve adoption. It would be nice to think that the improvement in supporting tools that we were talking about previously, that will just generally make for a nicer experience in the overall ecosystem. But that's obviously a little bit longer term. And I guess on a sort of very personal level, speaking with my standards guy hat on, seeing how pip can use good dependency data to produce a good result will encourage the community to think more in terms of providing that data, in terms of publishing the metadata statically, not building it on the fly, not sort of trying to say, well, we need this here, we need that there. If we can put all of that in a form that pip can just grab in one go, that will be yet further improvements. Having that data available will be really useful. And I think the new resolver, in my mind, will be a good showcase of how more data, more metadata, better metadata can improve the tools that people are using, and so will bring people's thinking forward on that score.
Yeah, and the other thing that, in addition to this standardization, the other thing is the tertiary effect, which Paul's sort of de-emphasizing of like getting more consistent information, good metadata from existing projects over time. I think in the longer term, that'll be the bigger, more relevant effect of it, since it'll push projects to be more correct about, hey, this is what I depend on. And that'll help reduce problems with the metadata itself, which right now Pip masks completely. And it'll start surfacing those issues with the new resolver. And those will start, in the longer term, getting fixed. In the short term, they'll be like a bit of a pain point during the rollout, possibly. I am not sure. That's what the rollout is for, figuring out. But yeah, in the longer term, in general, it'll push for nicer metadata, more static metadata, all of which will be bringing Pip more towards the nicer packaging experience than it is.
It's been a long road, and this is another step on that road. And I think looking to the future, we'll be continuing down that process for some time yet. But it's definitely another case of us going in the right direction, in my view.
In terms of your own goals, once this body of work is done, what are some of the additional changes or improvements that you would like to see or be involved with, either in Pip or some of the other core elements of the Python landscape?
So I think we've already mentioned a couple. One of them being static metadata, basically not having to do set.py, give me information step, and just going, okay, I can read this file and get information. So putting that metadata in PyProject.toml, like Poetry is already doing that today, but we want to make it possible for it to be done by all the tools, right? So having an interoperability standard about this. And there's some discussion happening. Poetry authors are involved, Pip authors are involved, set of tools authors are involved. We're all discussing this right now, and I expect that'll happen in the near future, although no promises on the timeline because it's all done on a volunteer basis. The other is that we have already mentioned also is being able to standardize a way for Pip and other Python packaging installers and environment managers or whatnot to get dependency information from a package index, whether it's PyPI or someone's Artifactory instance or something else entirely. Being able to get that information into the installer without needing to download, do a build, look at the results. And the third one, which is a lot more broader, is move further in the direction of having reusable libraries for doing these chunks of jobs in Python packaging. So going from a wheel to installing the wheel on the system, well, you don't really need Pip to do that. It's a well-defined step. Maybe we could have a library that Pip uses that actually does this. And then other people can use that library. Similarly, building packages. It's a well-defined process. It's just that Pip contains the only good implementation of it. Maybe if we make a common implementation that Pip also uses, everybody can use just that step. And sort of moving to these reusable libraries to decouple the ecosystem further from the implementation defined details of Pip, of setup tools, and so on, to being more general purpose and being more of wrappers around these libraries that handle all of the legacy options that they have and so on and so forth. And then letting newer tooling evolve, potentially replacements, potentially improvements to Pip, setup tools, whatnot themselves, that essentially allow for the evolution of the ecosystem as a whole, because that's the goal, right? To make things better as we go. And these reusable libraries and will help with that as well.
I want to second Pradyun's last point of reusable libraries. A lot of Pip's deficiencies came from the fact that Pip is a 10-year-old project that was designed to do something else than what it's currently doing. So a lot of the new packaging projects in Python are able to solve this problem better simply because they don't have the same history baggage Pip has. But but right now Pip is the only implementation that can do everything Pip can do. So by splitting out the reusable parts, it will be much easier for the community to come up with different solutions that fit the modern world better than Pip, while Pip can keep on doing what it does best and support those people that are already using Pip for niche applications.
Paul, do you want to add something?
I could thank you guys for being my standards cheerleaders. I think everything you said is essentially correct. With my role as standards person, that is absolutely my goal, is to make sure that the ecosystem is built in such a way that if somebody wants to come along and write a specialized tool for their particular use, they don't have to reinvent all the wheels that Pip has invented over time.
I mean, we already reinvented a wheel format, so we don't want to do more of that.
Pradyun, though.
I promised my
Sorry.
family I wasn't going to make bad puns on this podcast. You've just ruined it for me.
I'm sorry.
But yeah, I'm going to collapse in disarray now. Essentially, yes. Let's standardize stuff. Let's make it reusable. Let's give the community a chance to innovate in ways that it can't when everything's getting measured against, I'd love to use your tool, but it doesn't do this particular bit of what Pip does.
And then in terms of your experiences of working on this new dependency resolution algorithm and improving some of the overall implementation of Pip and paying down its technical debt, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
For me, I think I mentioned earlier, this is the first time I've ever actually been paid to work on Python. My day job does not involve Python except in very minor ways. And for me, oddly enough, the thing that I found remarkable was how different it was working on Pip as a full-time, well, in my case, part-time, but nevertheless dedicated piece of work rather than doing it as a hobby in my spare time. The ability to focus on the bigger problems, the ability to get deeply involved in addressing the difficult issues rather than finding an hour or two one evening to knock off a couple of little bits that have been bugging me. That's been remarkable how much of a difference it's made. And I don't think I had realized, even while I have said that one of the problems Pip has is a lack of resources. We've got, I'm not quite sure exactly how many maintainers we've got now, 5 or 6, all of whom are volunteer working on it in their spare time. I don't think I'd realized how much of an impact that has on what we've been able to do with Pip. If you look at a lot of the other language communities and their packaging solutions, a lot of them have funded work going on for them. If you look at Conda within the Python environment, that's got corporate support. But what Pip's doing is very much spare time. So actually being the really unexpected side for me was just realizing how much more productive it could be if we could get people working as a dedicated task on Python packaging.
Yeah, one of the more interesting things for me personally, and is like Paul, this is the first time I'm working on a project, getting paid to work on a Python project. It just so happens that it's also the first time I'm probably getting paid to do work because I'm fresh out of college, actually still in college. And I think over the past few years, one of the things that's been super interesting for me as a contributor is just seeing how different the ecosystem funding situation is. Because if I look at other package managers, NPM, Cargo, Bundler, all of those have some sort of big financial backing organization that's paying people full time to work on these things. And people coming from other toolings, other ecosystems, come in expecting Pip is working the same way. And for a little bit there, the reality of it was just a college student sitting in his dorm room and fixing those issues or responding to the issue comments. And it took me a while after actually having started working on this to go, wow, that was the situation this tooling was in, and that's not great. But the other part of it is it's been awesome to actually have funding to do this stuff, right? This is the first time that Pip's ever had funding go towards it. And kudos to everybody in the Python Software Foundation's packaging working group who made this happen. Yeah, it's just really different approach to working. The feedback loops are faster, at least compared to what they were earlier. They're not instant or super fast, but it's really nice to make this faster. The other probably thing I have learned would be just the sheer number of ways people use Pip. In the 3 years that I've been contributing / maintaining it, I have got a glimpse of it, but to actually have user surveys and see the results of those and sort of get that information in data form rather than a qualitative form has been really enlightening, to put it in one way, I guess. And the face-to-face time with other contributors has been really nice because, as I said, there's not been much resources. So we have not actually spent time discussing over calls about issues. Most of it has just been collaboration over comments on GitHub and mailing lists and discuss.python.org. And to have the ability to go, hey, do you have a minute to hop on a call and discuss this real quick? And getting a response within an hour has been basically amazing compared to needing to wait for 3 days to get a response to a detailed comment you made because it was too long to read for someone in the 10 minutes they had that day. That's been a big change and really nice.
So for background, I'm the only one of the three that was not a pip maintainer before joining the project. So my impression to the project is entirely opposite in a way. So this is not my first freelancing work. So I've been doing remote work for a while, but this is the first time I'm working with people real time in different time zones, literally half the globe away.
Almost everyone in the team is in a different time zone.
Yeah, I believe the 4 of us are in different time zones right now. So both Paul and Pradyun mentioned the feedback loop was fast. For me, the feedback loop initially was terribly slow because everyone was in different time zones and they are all working part-time, or because we are dealing with different parts of Pip, and even though we have 2 Pip maintainers, they don't necessarily have knowledge to all of the code in Pip. So sometimes we need feedback from other Pip maintainers. And comparing to a corporate setting, you can just walk by or just jump in, hey, maybe I will drop by tomorrow morning and see what we can work out. This doesn't happen with this project. So this has been a revelation to me. And it is also very, I think surprising is the wrong word. I'm very impressed how everyone has managed this project with so much restrictions going on. And it really takes everyone a lot of discipline, independence, and self-consciousness to push things forward.
All right. Are there any other aspects of the dependency resolution work that you're doing, or your experiences working on Pip, or your experiences of contributing to the overall Python community that we didn't discuss that you'd like to cover before we close out the show?
I think one of the nicer effects of this project actually happening, along with PyPI rollout happening earlier, is sort of acting as a showcase to the Python packaging ecosystem that, hey, we can actually get funding for open source projects to do stuff with. If we can show people that, hey, this money will be put to good use, it's possible for us to get and raise funding for targeted open source projects, which is a really good model for pushing open source tooling forward. because for end users, there's a clear expectation in what the funding should result in as an output for them, which is, let's be honest, how most funding works. And no one's going to give you money to do just whatever you want. And on the other hand, that funding can be used to improve maintainer availability, developer time availability, and improve the project not just in that one dimension, but also other dimensions, right? Put that money towards general maintenance as well. We've had a release process while I've been getting paid to work on Pip. And this release went fairly smoothly compared to the past ones because I had a lot more time to pay attention to details. And things like those are reasons that we should get funding into open source. And I think the model that this project shows of, hey, have a targeted project, raise funding for it, and get the existing maintainers to work on it is perhaps not sustainable, but definitely better than not having funding at all.
I think one other thing I would say, and this is, everybody says this, I'm going to be so unoriginal, it's not true, but it's been really, really enjoyable working on this project. I think the people in the Python community, the people people I've dealt with, make it so much fun. I've had a blast, and that is all down to the community as a whole. The support we get from the people using Pip, the support we get from the people working with us, it's amazing. And I think that's something that I think it's important to remember. We've got an amazing community, and it makes such a difference.
Yes, definitely.
Yeah, definitely.
It's been so nice to get like random tweets from people like, hey, this beta, like the alpha resolver works well, yay! And it's like, it makes your day. It makes you really happy that stuff that you're doing has almost immediate impact on users, and they're super stoked about it, and also motivating you and telling you, hey, good stuff. It's really nice. I interrupted Tzu-Ping, sorry.
No, I was just saying, I very much agree with what Paul said. I mean, I'm not going to say that it's been a blast, let's do it again, but maybe we can do it again for something else.
How much of that is because we've had to deal with a lot of technical debt, though?
I don't know. Maybe it's just very nice to have someone to talk to when you're hitting with like the technical depths. Like, you're not alone in this. There are other people also suffering from the same problems as you are. Yeah, so it's a very good experience.
All right. Well, for anybody who wants to follow along with the work that you're all doing or get in touch or get involved, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And so how about we start with you, Tzu-Ping?
The first one is PyLauncher from Brett Cannon, a core developer and also a member of Steering Wheel Council. Python Launcher or PyLauncher, I forgot the name. I'll provide a link later. So it's a project in Rust that when you type py in your command, it dynamically looks up all the Pythons in your system and launch the best one for you, and you can supply flags to it to let it choose maybe Python 2 or Python 3.5 specifically. So if you're familiar with Windows, Python has had a similar thing called Python Launcher for Windows, py.exe, which looks in the registry for install Pythons and launch one for you based on the arguments you passed in. But we don't really have something similar on Macs or Windows. So for Linux. And that has been a problem in tutorials because you need to provide different commands in for different platforms. And Python Launcher is a project that aims to solve this problem so we can have one canonical way to launch Python. And the other one is a book author, Joe Abercrombie. He writes fantasy novels. I've been reading his Shattered Seas trilogy, and it's been very interesting. And I've recently picked up the other series he had. I forgot the name, and I'm also really looking forward to it. And if you are into these kind of novels, fantasy novels, I highly recommend his writing. And the final one is maybe anime in general. So I know anime is not a big thing outside of Eastern Asia, and a lot of people think that anime is for kids, like cartoons. But comparing animes to movies is kind of like comparing Python to Windows, which does not really make sense. One of them is an art form and one of them is a media. So if you have been staying home for too long and are looking for something to pass time, I recommend maybe watching some more adult themed animes, and maybe you will find something suitable for you.
And Paul, do you have any picks this week?
I guess one of the things that I've found has been really useful for me, as part of this project, I had to set up a brand new laptop, and a couple of really nice tools that I've enjoyed using for that are on the Python side. There's a project called PipX, which basically lets you set up Python projects that work as sort of command line tools, things like Black, things like Nox, Tox. You can set them up as local little commands. They've got their own isolated environment. You don't have them installed within your own main environment, and they just run like independent commands. It's really great for managing all of those tools that make a PC turn into a usable working environment. And a similar thing that I use, I'm based on Windows, and finding all the little tools, things like Unix utilities, command line tools that you want to use. There's a really nice package manager that I've discovered and use a lot, which is called Scoop, which effectively manages you installing and uninstalling all those little tools that you want to get hold of just from a simple command line interface. It's really helped me set things up fast and not have to worry about, why am I on a PC that hasn't got such a thing installed again? So those are really great. I've thoroughly enjoyed them. And I guess following on from the theme of sort of what do you do while you're in lockdown, a guy I've read a lot of books by is Neil Gaiman, who I guess a lot of people will have heard of. His books, I think, are really amazing. He's done a lot of work on TV as well. I've recently watched the TV series of Good Omens, which is a thing he did with Terry Pratchett, which I thought was absolutely fantastic. I've thoroughly enjoyed watching that. I'd recommend it to anybody who enjoys either Terry Pratchett or Neil Gaiman. Well worth a look.
Since Paul just mentioned Scoop and PipX, I made a Scoop formula. I forgot the name. Scoop recipe for PipX, so you don't need to globally install PipX to your Python.
Excellent.
Well, Paul picked up PipX, which was going to be one of my picks. So I guess I'll keep going with the things that have kept me sane in this lockdown world that Paul picked up. I think two of them have been mostly recreational things, because I've had enough work stuff going on to keep me occupied, luckily. So it's been music by Chris Daughtry, who has been around since quite a while. He was like an American Idol contestant in 2006 and so on. And he's like an alternative rock band. Chris Daughtry's band is an alternative rock band. And it's a nice bunch of music. They have a really good discography. I don't know of a single song in there that I don't like. So that has kept me sane. The other thing has probably been Parkitect, which is an indie game where you build and manage an amusement park, basically. And it's sort of a really good way to put down a whole bunch of creative energy in one place and build stuff that at least makes me feel happy about them. So that's another.
All right. And for my picks this week, I just recently started experimenting with the language server protocol and its implementation in Emacs with LSP mode. And it's just a way of being able to have one way of sharing a lot of the IDE-like behavior between different editors. So things like completions and linting and being able to navigate to definitions or find references to different variables. So definitely a pretty great way of being able to have your environment easier to manage and portable across different editors. So been enjoying that and recommend that for anybody who's using any sort of text editing environment. And so with that, I will close out the show. I just want to thank you all for taking the time today to join me and share the work that you're doing on improving the dependency resolution in Pip. It's something that is going to benefit everybody in the community and something that I look forward to taking advantage of myself. So I appreciate all of your time and effort on that, and I hope you enjoy the rest of your day.
Thank you very much.
Thanks, Tobias.
Thanks, Tobias. Have a good day, folks.
Right. Bye-bye.
Bye, everyone.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.